Hey, so guess what? This is your last set of notes that has anything to do with light or sound or waves, anything like that. This is our last set before we start to review for our test, and then we have spring break, so get excited. This set of notes is going to be split into two separate videos. Once I looked over the notes, I realized that it might be a little long to try to cram it all into one video, and I don't want to make it take too long to buffer this if you're using a phone or an iPod to watch this. So just make sure you are on the lookout for the second video to get the second half of notes, and let's get started. So the electromagnetic spectrum is basically the entire spectrum of waves that travel in an electromagnetic fashion. So this means they have electric and magnetic fields that intertwine. They all travel at the same speed, but they have different wavelengths and frequencies depending on the type of wave that it is. So just a reminder, speed is equal to wavelength times frequency. So if I were to increase the frequency of a wave, what that's going to do is decrease the wavelength. If I increase the frequency, I'm also going to increase the energy. And if I decrease the frequency, I increase the wavelength. So those are all just things that we've talked about before. Just wanted to remind you of that relationship. I believe in the notes itself, I have switched by accident these two rows, so just be on the lookout for that. My bad, I forgot to change that little typo there when I made the notes, so just make sure you use the word increase for a wavelength there. So you're going to fill in electromagnetic spectrum in those two blanks, and this is the name for the range of electromagnetic waves that we have, and what we do is place them in order of increasing frequency. So basically we're starting from the lowest frequency, the longest wavelength, and we put them in order until we get to the highest frequency, which means they have the lowest wavelength or the shortest wavelength. So there are several different ones. They're called radio waves, microwaves, infrared rays, visible light, ultraviolet rays, and X-rays, and then gamma rays. And surprisingly, we can only see a tiny fraction of the spectrum of light waves that are all around, and that would be visible light. Everything else we can't see, but what's cool is that some animals can see outside of the range of vision that we have, and we'll find out about that in a few minutes. So the first wave in the electromagnetic spectrum we're talking about are radio waves, and this is going to be filled in to this blank underneath the little chart. This wave has the longest wavelength of all the electromagnetic spectrum, and that means that it has the lowest frequency, so the lowest number of waves pass through a given point in a second. So what happens with radio waves is that there is a source that sends out these signals, and it has to have a receiver that allows it to translate the information, and it also bounces it back to the source to have a complete circuit of the wave travel. And so this is used in radios. The number on your dial would be the frequency of the wave that is used. Microwaves have shorter wavelengths and they have a greater frequency than radio waves, so they're second in our list of electromagnetic spectrum. They can easily pass through glass and plastic, so you're probably thinking right now of an actual microwave in your house, and these use that type of wave to heat up your food, and activates or it heats up the water in the food, and that's why it doesn't really affect the glass and plastic, because it can just go right through it, and that's why it's better to put your food that you're heating up in a material like that. You really don't want to put metal in the microwave. Hopefully none of you have found that out the hard way. I know I did when I used to put, I would put like butter in the microwave for just a couple seconds so I could put it on some popcorn when I was a kid. And back then, I think they still do this, but on some of the butter, depending on the brand, it would be wrapped in this like metal sleeve instead of the wax type of wax paper sleeve that they have now. And not thinking, I put the metal sleeve around the butter into the microwave to heat it up for a couple of seconds, and sure enough, it started sparking. So please do not try this at home, and don't blame it on me if something happens, because the waves are reflected off the metal and they cause sparks, which can easily start a fire. So you really want to be careful with things like that. Other ways that microwaves are used are in cell phone signals. They're also used in radar. So when a police officer is sitting on the side of the road running radar, they're actually sending out signals that are bouncing off the car and coming back to him. through the microwave, which we cannot see, and he's able to figure out how fast people are going based on how quickly the wave is bounced back to him. Also, an MRI is using microwaves, and it makes an image of different parts of your body. I know some of you have had MRIs before. I had one last summer. I was lucky enough to have one where you can actually sit up in it and not have to be like pushed into the tube because I'm claustrophobic. So if any of you have stories about that, I'd love to hear about it in class when we're back together. Finally, this is the last slide in this video, and this is about infrared waves. It's always really hard to say that. This one has a shorter wavelength and a greater frequency than microwaves, so this is next in our line. Before, when we talked about sounds, we said that infra is the prefix that means below. So the word infrared literally means below red. So this is just below what we can see, because we can see the color red. What's interesting is that snakes can actually detect infrared, and basically what this is just like a thermogram, which detects like the different amounts of heat on the human body and just on all the surroundings, and so they can kind of get an idea of what's around them based on the heat that's coming off of the object. Heat bulbs also send off infrared waves to heat up objects. Also, if you've ever seen a camera that has night detection on it, a lot of times, like if you put that on, you can get a better image of what's around you, and that's again based on the heat that's coming off of different objects. So this is it for our first video. Stay tuned for our second video where we'll cover visible light, ultraviolet waves, x-rays, and gamma rays. Again, please don't forget to watch that video so you can get your second half of the notes, and I'll catch you there.